As global demand for energy continues to grow, as the world's population expands, and market dependence reaches a critical stage, financial markets will reflect our increased demand for energy supplies. The necessity to find new sources is apparent. As our global environmental concerns mount and emerging nations thirst, what is the solution? We call our brain trust the mothers of invention. The invention is drop blast. The result is fusion power. The leader of the Bubble Fusion project team is Dr. Robert Dean. He is an engineering expert in fluid dynamics.
Yeah, my field is fluids engineering. What we're going to talk about today, drop blast, is very much fluids engineering, and so it's perhaps natural that I am very much involved in the invention of this technology. I think we have a very, very strong team of people, and if I think we have a tremendous advantage over any other method that people have tried with bubble collapse to make fusion. We have a sledgehammer compared to a fly swatter.
Dr. Ron Roy has recently received the prestigious Eastman Chair at Oxford. He is a physicist, an engineer, and another member of the Bubble Fusion project team.
Hi, my name is Ronald Roy. I'm a professor of mechanical engineering at Boston University. I've been working at BU since about 1996. Prior to that, I was professor of mechanical engineering and bioengineering at the University of Washington in Seattle, in which I discovered bubbles, essentially.
You discovered bubbles?
Yeah, that's right.
Dr. Glenn Holt is a professor at Boston University. He is a physicist, an engineer, and a member of the Bubble Fusion project team.
What we hope to achieve in this first phase of the research project is simply this: fusion from cavity collapse in a drop blast stream. If we get that, we've hit the home run. And then we move on to later stages of the project. But if we get this, we've hit the home run. Fusion then is the goal. Some evidence of fusion, typically neutrons coming out. Well, that's the proof of concept. That's it in one sentence.
Busy in the IP garage, Jed Wilbur, research engineer and the youngest member of the Bubble Fusion project team.
You always say you can't get away from those bubbles. And it's actually my first introduction to bubbles. And of course, when you first hear about all these guys sitting in a basement lab studying bubbles, it doesn't sound like there's that much that could be done or that could be that fun or anything. But it's really quite fascinating. And there's a lot that goes on with them, as we're going to discuss, I'm sure. What's going on here is you're taking a bubble, you're growing it, giving it a lot of potential energy, and then you're slamming all that potential energy down and focusing on such an infinitesimally small point that you're releasing so much energy you see light, and you're creating so much energy that maybe the temperatures, maybe the pressures, maybe they're high enough that they sort of start to approach what's going on in the sun. And that, of course, is nuclear fusion. Two elements getting so close together under the intense temperatures and pressures that they actually fuse together and become a heavier element. The classic example, the one that powers the sun, the one that we're working with, is two hydrogen atoms fusing together and becoming one helium atom. And in the process, it releases a tremendous amount of energy. And if you can harness that energy, you've got pretty much an infinite supply of energy that would last the world. We're going to save the world with bubbles.